Bloomberg ran a story in April of 2019 that should have changed how the entire market thinks about voice assistants. Reporters Matt Day, Giles Turner, and Natalia Drozdiak spoke to 7 Amazon employees who worked on the Alexa voice services team. These workers, spread across offices in Boston, Costa Rica, India, and Romania, listened to audio clips captured by Echo devices in customer homes. They transcribed them. They annotated them. They passed particularly interesting ones around in internal chat rooms. Some of the clips were funny. Some of them, in the words of the employees Bloomberg quoted, were disturbing. A woman singing off-key in the shower. A child screaming for help. What sounded like a sexual assault. The employees were told there was nothing they could do about any of it. Their job was to tag the audio and move on. That story is where most people first learned that Alexa was recording more than they thought. But the technical reality of what these devices capture, when they capture it, and how the capture relates to the little blue light, ring on top, is still widely misunderstood 6 years later. The light being off does not mean the microphone is off. It has never meant that. Let me walk you through what is actually happening inside that plastic cylinder sitting on your kitchen counter. Every Echo device contains an array of far-field microphones, typically 7 in the taller models, arranged in a circle to allow the device to determine the direction a voice is coming from. These microphones are always on. Always. They have to be, because the device cannot know you said the wake word, Alexa, or Amazon, or Echo, or computer, until it hears you say it. Hearing it requires capturing audio continuously, running that audio through a local keyword spotting model, and triggering the full cloud pipeline only when the model detects the wake word with sufficient confidence. Amazon has been quite consistent in describing this architecture publicly. The company says audio is buffered locally in a short rolling window, typically around a few seconds, and only sent to the cloud after wake word detection fires. The light ring activates at that point to indicate that capture has begun. If the model does not detect a wake word, the audio in the local buffer gets overwritten and never leaves the device. That is the design. The problem is the gap between the design and the reality. First, keyword spotting models are probabilistic. They produce false positives. A Northeastern University study published in 2020, led by David Chofnes and colleagues, tested smart speakers from Amazon, Apple, Google, and others against a corpus of conversational television audio. The researchers found that Echo devices, across multiple model generations, triggered on non-wake word phrases multiple times per hour in normal household audio conditions. Phrases that sound nothing like Alexa to a human ear. Things like "I guess," "so," or "a letter," or "Alex was," would reliably cause the wake word detector to fire. When that happens, the light ring activates, the device begins recording, and the audio goes to the cloud. In many cases, the device realizes shortly afterward that the interaction was not intended, and it stops. But the audio has already been transmitted. Here is where the light ring problem becomes interesting. The ring is a visual indicator tied to the state of the cloud recording pipeline, not to the state of the microphone itself. The microphones are capturing continuously whether the ring is on or off. The ring tells you whether your audio is currently being streamed to Amazon servers. And in the false trigger scenarios, that streaming begins before you notice, and sometimes ends before you notice too. From the user perspective, the light blinked briefly in another room, and nothing happened. From the system perspective, 5 to 10 seconds of your conversation traveled over the internet, hit Amazon servers, was analyzed, and in some percentage of cases was retained in the voice training data pool that the Bloomberg employees were reviewing. Second issue, the mute button on the top of. Every Echo device is advertised as a hardware disconnect. Amazon has stated repeatedly that pressing the mute button electrically disconnects the microphone array from the rest of the system, and the red light that appears when muting is supposed to indicate this disconnected state. But the actual implementation on most Echo generations routes through the device mainboard firmware, which means the behavior depends on Amazon's firmware continuing to honor that user preference. There is no independent evidence that every firmware update has preserved this behavior identically across every model. Newer Echo Show devices with camera modules have even more complex muting states, and researchers examining the hardware have noted that the mute button is a logical control, not a physical switch cutting the audio line. For a genuinely paranoid threat model, you cannot verify that muting the microphone has actually disabled it. Third issue, and this is the one that most directly contradicts what users believe. Amazon retains voice recordings by default. Until a policy change in 2019, these recordings were stored indefinitely. After the change, users could opt into auto-deletion after 3 or 18 months. But the default remained indefinite retention. Even today, the default policy on a new Echo device retains audio until the user actively navigates into settings and changes it. The retained audio is accessible by Amazon employees and contractors for the purpose of improving speech recognition models, which is exactly what the Bloomberg story was about. The same story reported, and Amazon later confirmed, that location data was frequently attached to the audio clips. Not always full street addresses, but the city, the coordinates near enough to narrow down a specific neighborhood, or sometimes a specific residence. An employee listening to a recording of a domestic argument could, in some cases, identify approximately where in the world that argument took place. Let me pull in a fourth, and even less discussed issue: Alexa voice profiles. This feature lets the device distinguish between different household members by voice, which Amazon uses to personalize responses, purchase authorization, and advertising. Voice profile creation involves training a speaker recognition model on your biometric voice signature, and that signature is stored in your Amazon account. Biometric voice data is, by any reasonable definition, personally identifiable information of the most sensitive kind. It cannot be changed if leaked. A password can be rotated. A voice print is permanent. Now, the practical countermeasures. If you want to keep an Alexa device and meaningfully reduce the surveillance exposure, there are steps that work and steps that are cosmetic. What works? In the Alexa app, navigate to Settings. Alexa Privacy. Manage your Alexa data. Turn off the option that says Help Improve Alexa, which prevents your voice recordings from being used for manual human review. This does not stop recording or cloud transmission, but it does. Remove your audio from the pool that Amazon contractors listen to. Turn off the option labeled Use of Voice Recordings, which is the legal basis Amazon claims for the manual review program. Set auto-deletion to 3 months or shorter. Review and delete your recording history regularly through the same interface. All of these are real, meaningful changes that alter the data flow. What is cosmetic? The mute button is better than nothing, but it is not a hardware guarantee. If the firmware honoring the mute state gets changed by an update you never examined, you would not know. For a serious threat model, physical disconnection is the only guarantee, and that means unplugging the device when you are not actively using it. Some users have taken to plugging Echo devices into smart plugs controlled by a different ecosystem, specifically so they can power cycle the entire device without trusting its own mute logic. The broader pattern here is worth sitting with. The entire voice assistant category is built on a fundamental trade-off that the industry has been reluctant to state plainly. For the device to respond when you say its name, it has to listen for its name. Listening for its name means capturing all audio in the room continuously, processing that audio, and making probabilistic decisions about when to escalate. The system cannot be both always on and always private. Those two properties are incompatible by design. Some vendors have explored on-device processing as a way to narrow this gap. Apple's HomePod runs significantly more speech recognition locally than Alexa does, and Google's Pixel line has moved in a similar direction with on-device assistant. But Alexa, specifically, has consistently leaned toward cloud processing because the computational cost of running full speech recognition on the device is higher than Amazon wants to bear at the retail price points they are targeting. The business model is subsidized hardware, supported by ecosystem engagement, and cloud processing is cheaper to deploy at scale than putting serious neural accelerators into every $50 dot. There is a deeper question here about the choice itself. Having a device in your home whose function requires continuous audio capture is not neutral. It shifts the baseline of your domestic privacy permanently. A conversation with a family member, a phone call, a private moment, an argument, a medical discussion, All of it now takes place in the presence of a device whose owner is a company with financial incentives that do not necessarily align with yours. Even if Amazon executes their stated privacy practices flawlessly, which is itself an assumption, you have installed a condition of continuous potential observation in the rooms where you live. That observation changes behavior. Studies on what researchers call the chilling effect have shown that people modify their speech and their actions in rooms they know contain microphones, even when they trust the entity operating those microphones. The effect is not conscious. You do not think I am going to censor myself now. You just drift. Certain topics become slightly less comfortable to discuss. Certain moods get slightly more curated. Over years, the cumulative effect on a household is not zero. The final point. When people ask whether Alexa is spying on them, they usually mean, is Amazon secretly recording everything I say and analyzing it for advertising? The answer to that specific question, based on the available evidence, is no, probably not in the active malicious sense. But that framing misses the actual issue. The device is capturing continuously by design, transmitting substantially more than users believe, retaining recordings longer than users believe, exposing that audio to human contractors in a non-trivial fraction of cases, and shifting the privacy baseline of your home in ways that persist whether or not any specific act of misuse ever occurs. If you decide the trade-off is worth it for the convenience, that is a reasonable decision to make with eyes open. If you decide it is not, you unplug the device and you use a phone or a screen for the same functions, which come with their own trade-offs, but at least are not always listening to everything. The light being off does not mean the microphone is off. The microphone is always on. That is the design. Everything else flows from that one fact, and the more you understand that, the more rational your choices about these devices become.